Hello, welcome teachers, students, school candidate, private candidate. Welcome to our lesson for today. Our subject is chemistry and this is chemistry practical. Our topic, qualitative analysis. We're going to learn about the salt analysis. During the preparations of examinations, if you are the student, you are going to sit for examinations, you have to know about the salt analysis. And the previous lesson, different lessons, we talk about we make analysis of different salt according to the groups. We have nitrates, we have sulfates, we have carbonates, and we have chloride salts. So, and we have said that after analysis, we are going to make analysis of each salt. How to write an analysis report or salt analysis report for qualitative analysis. So welcome to this lesson to understand, to know how to record a report and which step we are going to follow. So if you are the teacher, welcome to gain another concepts. If you are willing to listen this one, and then I'm sure you are going to be fit in your lesson of chemistry practical. So for today we are going to use to start with the zinc nitrate as a salty compound. This is zinc nitrate, and the appearance of zinc nitrate, this one is white and there is a crystalline. So that is the appearance. And we are going to use a qualitative guide sheet or level or for secondary examination. This is our salty analysis guide sheet, qualitative analysis guide sheet. That is our guide, and this is the normal guide sheet we are going to use for analysis of salt during the examinations. So you have to follow me here, and then at the end you will be able. So zinc nitrate, we are going to see how to write a qualitative analysis report for zinc nitrate. The first appearance, and you will see how to record at the end of this lesson. You will see the whole report for zinc nitrate, from the appearance of preliminary testing to testing solution, and then a confirmatory test, and then you will see the conclusion within at the end of this table of analysis. Appearance within a sheet when you perform appearance is this one. Appearance of solid sample. We have color, we have texture, we have the liquescent, we have smell, and so on. But during the appearance, we have to join. The first zinc appearance of zinc is white. So if you see is white, and the inference represent that white represented by ammonia, sodium, calcium, zinc, lead may be present, and there is absence of transition metal, which is iron 2, iron 3, and the copper 2 ions. Those may be absent. So when you see white, it means those transition metal are absent, iron 2, copper, iron 3. So our expectation at the end of this report, we expect to get ammonia, zinc, calcium, zinc, sodium, calcium, zinc, and the lead only, not the other iron 2, iron 3, and the copper. So crystals, texture, we have crystalline form. When you see this crystal expectation, we get a nitrate, sulfate, and a chlorine, and not otherwise not carbonate, and not hydrogen carbon. That is a crystalline form. So our sample appearance is white crystalline form, and we have to join this sentence, this and this one. We have to join this. It means we expect to get this one and this one. So when you join in inference, you have to report that nitrate, sulfate, chlorine, of sodium, of ammonia, sodium, calcium, zinc, and the lead may be present. That is how to join. And if your sample there is absorption of water, you have to write appearance is white crystalline form, is white crystalline form, and then you have to join this and absorb water from atmosphere to form a solution. And when you join inference, you have to write nitrate, sulfate, chlorine, of ammonia, sodium, calcium, zinc may be present. That is how to write your appearance. I think you will see on the whole report to know how to write it clearly. Another test, flame test. When you take the flame test or perform flame test, make sure you have concentrated hydrochloric acid and you have test tube or nichrome wire, or you can have a rod or glass rod. So among of these, you have to choose one, either test tube or glass rod or nichrome wire, not both. And then after you have this one, you have to dip to make sure you mix a small amount of sample with the concentrated hydrochloric acid, and after you have to clean your nichrome wire or test tube, your glass rod, by using these steps. You have to dip in concentrate and then you heat. That is, you clean the apparatus which you are going to use to test the flame test. After cleanness, you have to dip either test tube or glass rod. So myself, because glass rod can be unavailable, nichrome wire can be unavailable, but you can have a test tube. So on the back of your test tube, you can dip within a concentrated sulfuric hydrochloric acid contain a solid sample X, which is zinc nitrate, and then you test it on a flame. That is how to write. And then the observation, it means we expect to get this one, and our inference will be this one. No definite color observed. Zinc and ammonia may be present. That is the flame test. Action of heat of solid sample. You transfer a small amount of solid sample within a test tube which is clean, and then you are going to perform action of heat. Make sure your test tube is dry to avoid a dissolution of your sample. It means when you perform heat, action of heat, it means you heat strong. You have to heat strong. It means you decompose the compound to get two different products, and we expect to have residue sometimes. So during our test of zinc, we expect that to have first, because this is nitrate, expect to get reddish brown film. There is a film of brown that is like a smoke, which is brown. That is how to write on this. And then on the action of heat zinc, there is two observation. We are going to get a residue yellow when hot, and the white when cold, represented by zinc. So when you heat zinc compound, we get yellow when hot, and then when it still is going to be cold, it changes from yellow to white. So this is observation: yellow when hot, residue, and the white when cold, and the zinc may be present. Action of dilute hydrochloric acid. You take solid sample, you put in a test tube, then you dissolve in dilute hydrochloric acid. Of course, we are going to see no effervescence because this is not a carbonate, and the white precipitate. This is not lead, because when we see in action of heat, residue yellow and hot represented by zinc. So we can't expect to get lead, because in action of heat, lead we can expect to get reddish brown when hot and the yellow when cold. So this is not correct. So when you see this is the lead, this is wrong in zinc nitrate. So that is action of heat. We have nitrate and the zinc or brown fume, and the reddish yellow when hot and the white when cold. And the diluted hydrochloric acid, there is no gas evolved in our sheet, no gas evolved. And they have to avoid copy and paste from your sheet, because this, you see this no gas evolved, you have to write no gas evolved, because on the spot you perform the action and you see what happened. So you have to state this is no gas evolved, because this is sheet is prepared in frequent reaction. It means always when you test this will appear, so that we use evolves. But in your testing you have to use on the spot action, no gas evolved. And the influence represented by sulfate nitrate chlorine. You see there is nitrate there, may be present. Action of concentrated sulfuric acid. You take sample, you dissolve in concentrated sulfuric acid. Actually at the end you have to warm slightly, and then brown fume will be evolved. Also you have to write brown fume evolved, which turned the moist litmus paper ready, and the addition of copper tannings. But this brown fume is enough to show you this, to show you that there is nitrate, even if you haven't litmus paper, even if you haven't copper tannings. Nitrate may be present when you see brown fume. That is action of the concentrated sulfuric acid. Then at the end you have solubility, to dissolve a salty sample X in water. We have the soluble form in the colorless solution, because our sample is salt, which is white, and represented by we are going to dissolve, and will dissolve to form a colorless solution, soluble form in colorless solution. So what is the expectation of the influence? We have sodium, ammonium and nitrate. Carbonate, there is no carbonate, because this is not a powder, this is a crystal. Chlorine of zinc, no. We have C brown fume, we can't expect this is chlorine. Also sulfate of zinc, no. We have seen there is brown fume, so sulfate cannot expect it to get brown fume. So sulfate of zinc, no, not influence. The possible influence with this one within our test of this one, and within our test of solubility. Our test of solubility, that is our testing for solubility, observation, and the influence. And then after solubility we are going to perform testing solution. Testing solution means we have to prepare a stock solution. The stock solution, it means we take a sample, solid sample, we dissolve in water, we check there is, we make stock solution for further testing in testing solution until to the confirmatory test. So you have to transfer first a small amount of solid sample in a test tube. Then you add enough water, you shake thoroughly. If you see there is soluble, that is a stock solution. But if the sample is insoluble in cold water, you have to warm the content on a flame or on a heat to see there is at least a dissolution of the sample. And if there is a resist of solubility, you have to transfer a new solid sample. You have to exclude the first. You have to take a new sample. You dissolve in a test. You put in a test tube, and then you dissolve in dilute nitric acid, and that one you get a final solution. Then you perform another test. So the first testing solution, you have sodium hydroxide on a sample solution. After testing, after making stock solution, it means we have a stock solution. We are going to put sodium hydroxide, we test it. But according to our sample, zinc, we expect to get zinc observation white PPT or white precipitate is formed soluble in excess. And our influence represent zinc lead may be present. And then action of ammonia solution. Because our sample is zinc, we have expect to get this one. You put ammonia in a solid sample solution, not solid. And then that is testing in solution. After looking from preliminary testing, we have this influence. We have zinc. You see here we have zinc in the lead, and then we have another test. We have this one. We have nitrate on the influence. We have zinc. You see there is nitrate, and then we have nitrate, sulfate, chlorine, and ammonia, sodium, calcium, zinc, lead may be present. And then to perform testing solution, we have to consider those from preliminary testing and to testing solution. We are going to see the influence appeared most frequently, the first. And then after looking that element appeared, that ions appeared in influence in most time, we have to see the reagent present in a table. So we start the compound which is appeared most frequent. We see there is zinc, the first zinc. So we are going to see in confirmatory testing how zinc is be confirmed, how zinc be confirmed. So in order to confirm zinc, you see here there is a confirmatory test for zinc. It means you have a small volume sample solution. You have potassium hexacyanate or potassium ferrocyanide solution, followed by dilute hydrochloric acid. Hydrochloric acid is normal solution, and then you have ferrous sulfate, ferrocyanide, potassium. So if you have this reagent, you test it on your sample, and then if it's zinc, and according to the sample is zinc, we expect to get bluish white precipitate insoluble in dilute hydrochloric acid. And then if you have ammonia solution, we have C. Ammonia solution is really different from the previous. We have to use also, we get this one. Also, you can use to test the zinc. So zinc confirmed. And then we have another compound. We have C. There is lead. There is ammonia, sodium. Actually, we haven't a reagent present for lead because we haven't potassium iodide. So if there is no reagent available for testing another compound, let's say lead, that's you are testing, and then you take your another procedure. But in an ion, mostly compound or most ions appeared is nitrate. We have seen there is sulfate, there is chlorine, but it appeared in most time or most frequent time is nitrate. So let's we go to test how nitrate being tested. Nitrate is an ion. We see nitrate is tested by two reagents. The first we have dilute sulfuric acid and the ferrous sulfate and the concentrated sulfuric acid. If you have these reagents, you have to test, and then at the end you get a brown ring at the junction. When we see junction, it means the test tube there is a junction. It means within a test tube there is two solutions. It means at the middle there is junction, the upper and the down and the lower. Within there is a junction of the liquids, and that represents nitrate confirmed or is present in your sample. And then if you have copper tannings or you have concentrated this one, you take original sample, solid sample, you test this procedure, and then brown film will evolve. If you see brown film, that is nitrate confirmed. So after confirmatory of these anions, and then we are going to see how the report we have performed is going to be in our answer sheet. So we proceed to see the report. Zinc nitrate, how you have tested it, you see the choice from the guide sheet, and now is presented in our another answer sheet. So first, the appearance of solid sample X, you have to include the name of the sample. We have said this is sample X. So appearance solid sample X, we have join white, this is color, crystalline, this is texture, and absorb water, this is the liquescent. Appearance of solid sample X, white crystalline form and absorb water from the atmosphere to form a solution. You have to write in this sentence. If you decide to separate, there is no problem, but the best way is to join. And the inference is this one, you see. Nitrate, sulfate, chlorine of ammonia, sodium, calcium, zinc, lead may be present. And the flame test, a cleaned nichrome wire or grass rod. So in this one you have to choose. If you want to use back side of the test tube, you have to choose one. So if you choose the test tube, you will see a clean nichrome wire. A cleaned back side of the test tube was deep in concentrated. So we remove this one. It means we still with the back side of the test tube was deeply concentrated. So the concentrated hydrochloric acid containing sample X. Containing sample X. Sample X in watch glass, then heated. This is heated because this is past tense in a non-luminous flame. No definitive color, no definitive flame color observed. The present zinc ammonia may be present. Action of heat on a solid sample X. You see there is a change of tense. A small amount of solution was transferred in test tube, then heated gently and then strongly until no further change. And gas evolved, tested, and observed the appearance of the residue. Reddish brown film evolved, and the note evolves as written in the sheet. When hot, action of heat, we have this one and this one, represented by this one. That is the way on how to write. We have said this evolved and turned, not turns, and the note evolves. Action of dilute hydrochloric acid, this one, a small amount, transferred, followed by this one. No gas evolved, and the note gas evolves. So sulfate, nitrate, chlorine may be present. Action of concentrated sulfuric acid, a small amount was transferred in a clean and dry test tube. A small amount of concentrated sulfuric was added and then content warmed gently. Have to change this sentence. Brown film evolved, which turned moist litmus paper red and intensified on addition of copper turnings. Nitrate may be present, and that is a report. You see how to write, and at the end of the analysis of your sample. That is confirmatory test. There is no need to write confirmatory test because this will inform that is confirmed or that is confirmatory procedure. And the brown fumes evolved. A small amount of the original solid sample X was transferred into a test tube. Copper turnings were added, followed by concentrated sulfuric acid and warm. Brown fume evolved, and the note evolved. Nitrate confirmed, and at the end conclusion, the cation in sample X was zinc, zinc 2 ion, and the anion in sample X was nitrate ion. I think that was a lesson for today, to show you how to make analysis of zinc nitrate, and this is the report for the whole test for unguided question. But if you have guided questions, I think within these steps, this is the whole step for analysis. But if you meet with another choice excluding of the steps, it means you choose one and you see how to read the steps within this whole document. This is reporting for whole. If there is another step excluded, I think there is another step will be included. That is our lesson for today, or for the first analysis, zinc nitrate. I think we end up here. You have understood. Just you can ask through my number. I'm going to put my number there, and you will see, you will ask for more questions. Thank you for learning with me. I think you have enjoyed this lesson. We proceed another lesson for another time. Thank you for learning. You have a nice day.